All right, hello all. Today my task is to talk to you guys about hypothesis testing when dealing with two samples. It follows the same concept as one sample, but now we're comparing two samples to determine are these samples equal according to the status quo or not? Is one less than the other or not? Is one greater than the other or not? We're looking at two sample hypothesis testing. So you guys are going to get to compare this compared to that. A good example of this is my class compared to another class. Are they equal? That would be like the null hypothesis, it is equal, all right? Or is the students in my class perform less than other classes, all right? That will be a left tail test, less than. If the students in my class perform better than other classes, that will be greater than, all right? So we're looking at two samples to determine whether to accept or reject the null hypothesis. Let's go, let's go, let's go, let's go. All right, so what I'm gonna do is share my screen with you all. All right, now you guys can download chapters 10, all right? If you guys go into course material or class resources, click on class resources, find chapters 10 homework assignment. For my classes, you can find that within chapters 10 assignment, all right? Grab it, download it, and then also, if you can, go to Cengage and log in there, please. All right, so I'm gonna hide this and we're gonna get this rocking and rolling. I have my Excel document right here. All right, so we're looking at two samples. Believe it or not, guys, it follows the same exact concept as hypothesis testing, a one sample hypothesis test. Watch at the alternative. Do you see in the alternative? Let me zoom up in here a little bit more. Scroll down. In the alternative, if it's pointing to the left, it's a left tail test. If it's pointing to the right in the alternative, it's a right tail test. If it's equals to, not equals to, it's a two-tailed test. So based on these samples, you can determine whether it is accepted or rejected. Now, don't think of it as two samples you will see on this normal bell-shaped line or curve or whatever. It's one sample or one test statistic as it relates to the two samples. So if your one test statistics fell in here, you would reject. If it fell out here, you would accept. Accept, reject, accept, reject. All right? Same concept over and over again, but this time we're dealing with two samples. Same thing as before for the known mean, all right? For the known, if we're dealing with population standard deviation, unknown mean or known sample standard deviation, and then also for the proportion. All right, so with that said, I think we are ready to rock and roll. Let's go to exercise 10.02, please. 10.02, scroll up to the top. And let's find that in Cengage, 10.02. All right, keep searching for it. If you already found it, good job. Here it is. I'm going to slide this over. I'm going to use that. All right, and I'm going to make my Excel just a tad bit smaller so I can see it all. All right. So right off the bat, y'all, you can tell whether this is a right tail, left tail, or two-tailed test. Hopefully, because you see greater than in the alternative, you will say, yo, this is a right tail test. You got it right. All right, so they're gonna provide you the two sample information right here. You guys can find the test statistic, the p-value, and answer these questions accordingly. So plug in what you have, please. Remember, junk in equals junk out. Plug it in, plug it in, plug it in. All right, population standard deviation, bam. Cool, cool. and then 7. All right, so you got your 2 right here. You got your sample 1, you got your sample 2. Note to self, your hypothesized value for a 2-sample test is always 0. Don't mess with it, leave it alone. I mean, for the most times, it is 0. There are occasions where it's going to be an actual number, but I believe on this homework assignment, it is always 0, all right? Unless they specify, unless they do something like this with a number right here, it's normally going to be 0 for a 2-sample test. All right, so on here, my alpha value is 0.05. My alpha value is 0.05. Therefore, my coefficient, my confidence coefficient is 95%. All right, so we already got everything filled out right here. Once again, just like before, we got 2 tests that basically mirror each other. All right, we got the z-stat and the p-value, the alpha test and the test statistic test. All right, so now here it says, what is the value of your test statistic, your z-stat value? All right, and they want 2 decimal places. Check your work just to make sure you're good. Cool, cool. All right, what is your p-value? This is a right tail test. So you're looking for your p-value for the upper tail. All right, plug that in, and it says rejected 0.0319, 4 decimal places. Cool, cool. Check your work. Outstanding. All right. So do you accept? Do you reject? Plug it in, and hopefully you can get it. All right. P-value is greater than, less than. All right. Do you reject? It says rejected right here. It actually gives you the word. All right. Do not reject or reject, and you can get your answers. Hopefully this is making sense so we can flow through it. If for some reason you want to find out the calculations that we did, everything is to the left and the answers show up to the right of it. All right, the formulas are showing up right here. So if at any time you want to figure out how did we actually did what we just did, what we just did, please look at the formulas to the left. All right, it's pretty interesting. All right, cool. Let's move on to 10.05, please. Make that a little smaller. 10.05. Bam. All right. So in this one, they're providing you the word problem. All right. I'm not going to take the time to read through all of this. What I normally do is look at the numbers, plug it in, and then answer the questions. All right. For me, the wording might be a little confusing. All right. So what I do is I look for the main things that I need and I plug it in. So we got the average expenditure on Valentine's Day expected to be this amount right here. All right. Do males and female consumers differ in the amount they spend? All right. So the average expenditure in a sample survey is of 50 males. All right. What consumer was this? This is how much males paid on Valentine's Day. So let's do males first. The average is that number, 131.84. All right, plug in your numbers, please. All right, and a sample size of 50 males. All right, so we spent $131 on Valentine's. Pretty good, guys, pretty good. All right, and the average expenditures in a sample survey of 38 females. All right, we got 38 females. How much did you guys spend? $61. Well, what? All right, I'm gonna need some more money spent on me for Valentine's. I know I'm taking it personal. Anyways. All right, what is my population standard deviation? For the males, it's 34, the spreadness of my data. So males could go all the way up to basically 160. Rocket, fellas, all right? For the female, the spreadness is $12. Good night. All right. We're not gonna judge, we're not gonna judge. All right, so let's do this. the expenditure in this one, and this is a good example of when it's not zero, I believe the hypothesized value in this case is 189. All right. Now we're checking to see. Now in here, I'm going to look for anything that says greater than or less than. All right. Expected to be this. This is the average. All right. So therefore, I don't see anything that says less than or greater than. So I'm just assuming that this is going to be a two-tailed test. All right. We see a confidence level of 99%. The alpha value is 0.01. All right. So we got everything here. All right. What is your point estimate? So you look on here and look for point estimate. You see that 70.2? Plug in your number, please. Right here. Right here is my point estimate. All right. You can see how they're doing the difference between the two. All right. So 70.2, check your work just to make sure. Bam. All right. What is your margin of error at 99%? All right. Look on here. Look for margin of error. Bam. And they don't tell you how many decimal places. Oh, 2 decimal places up here. So 13.36. If they don't tell you, you can just assume it's 2 decimal places. All right. And then on here, what is your lower and upper limits? All right, so you might have to scroll down. All right, here you got X1 lower, X2 upper. All right, so here are your lower and upper limits and 2 population mean. And all right, so everything here is 2 decimal places. Plug in your numbers, check your work. All right, and you should be good to go. So in this example right here, that's why I said for the most times it is 0, but if they specify what that value is, you just plug it in. All right, and you're just checking to see if these means line up with this value right here. All right, so if this is a two-tailed test, you would reject that these two are equal, if that makes sense. All right, based on this $100 hypothesized value. All right, let's go to 10.07, please. I thought I saw that on the bottom, or was that on the top? Yeah, all right, I gotta go hunting. All right, so right off the bat, you got your sample size 1, plug it in. Sample size 2, plug in your known goods. Just like we've been doing throughout this course, plug in what you know. 85 and 86, they're pretty close. All right, so I don't know if we'll have any major issues. All right, so this guy right here, all right, the hypothesized value is 0. All right, but what is my population standard deviation? And what is my population? All right, so let me look here. All right, an overall satisfaction score rating for each respondent with 10, meaning the respondent is completely satisfied in terms of all factors. All right. I am looking, okay, so here is my population standard deviation. All right, assuming that experience with consumer reports, blah, 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 that the population standard deviation of 12 is a reasonably assumption for both retailers. So both of them have 12, all right, with 0. All right, so as you can see right here, do not reject. All right, but in this question, is it a two-tail? Is it a left tail, or is it a right tail? So I'm just browsing really fast. national largest supermarket. Okay. The value, blah, 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 blah. I'm looking for anything that says increase in or decrease in or larger than or less than for two retailers, the consumers, student moods. Okay. I'm going to make the assumption that this is not equals to in the alternative. Check my work. All right. So this is a two-tailed test. So for a two-tailed test, it says do not reject. So what is your p-value for a two-tailed test? And I'm going to scroll down. Okay, two-tailed p-value. Plug that into 3 decimal places, please. 0.331. Check your work. All right, good. And what is the lower and upper limits? Lower and upper limits right there. So negative 1.01. All right, and in my case, check your work. Outstanding. All right, so the cool part about having a good template is you got a whole bunch of formulas and you don't have to stress yourself out trying to calculate them every single time. Once you have a working template, you have a working template that works. All right, just switch out the numbers, get your values, and keep it pushing. Wherever God places you, you don't have time to sit down and calculate each one of these manually. It takes too long. There's no way you're going to be able to get the work done, especially when you're dealing with a data set that is a gazillion data points. All right. You need a fast process. And that's why we're trying to train you on these templates, to get the concepts of these templates, to set it up, make sure that they're working so that you can replicate your work. All right. Good work, good work, good work. Let's move on. We're going to go to 10.10, please. 10.10. All right, so this is for your known sample standard deviation. So they're going to be giving you some sample data. I got to make that smaller. Perfect. All right, so this is 10.10. Okay, 13, 25. Okay. All right, here we go. So right off the bat, you should be able to tell if this is a right tail, left tail, or two-tailed test. All right, equals to, not equals to is a two-tailed test. Plug in what you got. Plug in what you got, please. All right. All right. And I'm going to make the assumption, well, I don't need to make the assumption. My hypothesized value is 0 in this example. Yes, 0 and 0. Oh, that is my, okay. So this is a two-tail, sorry. This is identify, this is two-tail. You can just type in two-tailed. All right, two-tailed. Or you can put one for the null and one for the alternative. One is equals to, one is not equals to. So just put two-tailed, that works. All right, so now that I got all of that stuff, I already got all the answers that I need out of this. What is my test statistic? T-stat, all right? And they want 2 decimal places. Guys, make sure that you're setting this up. If you're using the yellow parts right here, you can make sure that this is correct so you know which answers to select. All right, so for example, if you're gonna use this yellow, just put equals to, all right? And grab your test statistic. Where's it at? This guy right here, click it. All right, so that's gonna be B22. Press enter, and that will give you 2 decimal places. All right, I know you guys probably can't see that, but That is my answer. Let me zoom in so I can see it a little better. All right. What is my degrees of freedom? You can put equals to. All right. Round down to whole number. Round down to whole number. All right. So let me see. Degrees of freedom. Is there anywhere on here that gives me my degrees of freedom? Okay, degrees of freedom right here. All right, press enter, and I will have my degrees of freedom. And they want round the answer to the previous whole number. So that's why it's saying round down. All right, so the previous whole number is 67. Let's see. Uh-oh, error, check your work. There you go, so 67. So round down. All right, so what is your upper tail area? All right, so put equals to. I'm gonna slide this over, upper tail. Let me see what they're asking for here. Okay, so you guys can figure this part right here for your upper tail, p-value. All right, and you can get that if you're looking at an upper tailed p-value test or value. You can find that. All right, so upper tail p-value. All right, two tail values right here. You can plug those in. All right, and get your answers. All right, let's move on to 10.13, please. So let me go back over here. Let me click, let's delete that, enter. All right, you guys can figure this out. Make sure you're documenting it. So if this shows up on the exam, you are good to go. All right, so 10.13, 10.13, two samples again. All right, you can plug all your stuff in here. All right, so this one, you shouldn't have to download anything. It's already here for you. But if you have different numbers for some reason, you can plug in your numbers right here. So 10.13, 25. Okay. So yeah, 52.8, good, 42. All right, so these numbers are correct. You have two sample data. And the question is, let me make this bigger so we can see this. The question is, can you find all of this value right here? So how do you find this first one? So let me zoom in just a little bit more. Too much. All right, right there. All right. So if you double click and grab the formula, count, copy, you can paste that in there. What is the range? The range of all your numbers for the first sample, private. All right, and press enter. Paste that in there again, double click and highlight. Make sure you have the equals to sign. If you do not have the equals to sign, you will not be able to highlight range and grab your numbers. All right, so how do you find the mean? Guys, hopefully by now you know how to find the mean. It's the average. All right, so double click in there, grab the range, double click on the range, grab the numbers, click and grab the numbers. Paste that in there, double click the range, grab these numbers. All right, standard deviation, same concept, grab it, paste it. Paste it. All right, we're gonna, the hypothesized value we're assuming is 0. So I'm gonna put that over there. I'm gonna make that just a tad bit smaller so I can see it all. I'm gonna scroll over like that. All right, so we got that, we got that. All right, is this a right tail, left tail, two tail test? You guys can look at this data and figure that out. All right. So on here, let me see quickly. I am looking for anything that says less than random selected. All right, I don't see anything that says freedom to the preceding whole number. Okay, I don't see anything that says less than, greater than, so I'm gonna assume that it's a two-tailed test. All right, so two-tail, I'm just gonna put 2T, 2T, 2T for two-tailed. All right, so we got everything that we need. What is my X1 value? What is my mean value? All right, 42.5. And they want 2 decimal places. All right, and I'm gonna plug in my S2 value. I think, let me make that bigger so I can see it, 5.3 instead of 5.9. All right, here it says, what is my point estimate? So you look on here, point estimate. Let me see the point estimate. All right, so 20.2, and they want 1 decimal place. Just check your work just to make sure you're on the right path. All right, good, 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 good. All right, here you guys can plug in, interpret the value in terms of the annual cost of attending private and public college. All right, that might be difficult for you guys to interpret. So right here, it's the mean annual cost times 1,000. So you're taking the point estimate times 1,000 to get this value right here. What is your lower limit? What is your upper limit to get these values right here? Hopefully these concepts are making sense. Having a good working template helps you simplify it. Instead of going through the stress of all of these formulas, you have a nice organized way of doing it to get your answers fast. All right, with that said, let's go on to 10.19, please. 10.19. All right, here we go. Right off the bat, you should be able to tell this is a right-tailed test. In the alternative, it's pointing to the right. All right, so plug in your numbers, plug in what you got. Remember, junk in equals junk out. All right, so this one. All right, so this one is pretty simple. All you got to do, all right, is run within Excel. You can actually run a matched sample. All right, you have 2 samples. You can actually do this, and within 10 seconds or so, get this answer right here. So what I'm going to do is I'm going to maximize this. It kind of shows you an example right here. But basically what you're doing is data analysis. And what we're doing is we're selecting t-test paired to sample for means. So scroll down, t-test paired to sample for means. All right, these other ones do similar things. Let me make sure paired. Yep, okay, I got the right one. Click OK. All right, what is your sample one's input? All right, so if you click on here and scroll back over, here's your sample 1. I like to include the label so I know that I'm dealing with pop 1. All right, for number 2, click it, select it. All right, for my hypothesized value, I'm going to make the assumption that it's 0. Unless it's telling me something different in Cengage, I will change it. I'm going to select label because I did select my label. And I'm going to put my output right at this orange box right here. Click it. It should say F2. So it should look like this. And within a couple of seconds, if you press OK, override it, bam, you should have your data set just like we did with our templates. If you guys get these concepts of these templates, you can actually create a data analysis toolkit that looks just like this. All the calculations are already calculated for you. All right. So here it's saying, how do you find the average? All right. How do you find the standard deviation? How do you find the p-value? all right? The p-value, if this is a two-tailed test, all right, is right here. If it's a one-tailed test, is right here, all right? And then what conclusion can you make? So what I'm gonna do is slide this back over. I'm gonna actually look at this right here. All right. So it says, what is the difference? So within our thing right here, it shows you your differences right here. So you can just plug in your numbers, check your work. All right, what's the difference between 21 and 21? Okay, hopefully that makes sense. Compute the D. All right, compute the D for B. All right, so we can compute the D. All right. Well, what is the average in other words? So what we did was, it's the average of D4 through D8. So it's the average of all of these. That's how you calculate your differences. So copy this, paste that. All right, so the average of all of that is 1. All right, so let me check my work. Where is it hiding? Just to make sure. Perfect. What is my standard deviation? All right, and this is just based on the differences. So copy this, paste this. Once again, this is why we provide you a template. All right, that one is 1 as well. All right. And you are good to go. Then you can answer these questions right here. So on here, your p-value, all right, how would they do this? It's between what? So you gotta find out if this is a right-tailed test or a left-tailed test or a two-tailed test. So on here, okay, so this is a right-tailed test. This is a right or a one-tailed test. So your p-value that you're going to be using right here is this number right here. You see p, one-tailed? So this is the number that you're going to try to find out what that value is in between. Let's go, let's go, let's go. All right, hopefully that makes sense to you. You can figure this out. All right, let's go to 10.25, please. We got 4 more to go, 10.25. All right, so you got all these scores right here. So you got your math scores, you got your EBRW scores, you got your students, your math, blah, 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 blah. But watch this, guys. Your math scores, all right, it just continues to this one right here. So all of your data should be correct up here and here. So now let's do a t-test pair to sample. All right, so I'm going to maximize this. I'm going to do data analysis. I'm going to go t-test. All right, pair to sample for means, click on OK. All right, so in the first one, include math, go all the way down. Highlight this, include write-in, go all the way down. 0, label, we're going to put our output right here, right at D2. All right. So grab that, make sure yours match, and click on OK. All right, OK. What is your test statistic? This is equal to this number right here. What is your p-value? Is this a one-tailed or a two-tailed test? So I'm just going to go back to Cengage. All right, and what I'm looking for is anything that says less than, greater than, or anything like that. Let's see. And I'm just scrolling through. Once again, I'm just browsing. P-value, round off decimal place. Okay, the test statistic, enter the negative number. Good, good, good. All right, so I just don't see anywhere that says less than or greater than or any of that stuff. All right, so what I'm gonna do is I'm gonna say that this p-value is equal to this number for two-tail right here. All right, so let's check it out and let's see if I'm right. How do I calculate my point estimate? It's the mean of 1 minus the mean of 2. So if I put equals to mean 1 minus mean 2, that will give me my point estimate. So let me at least plug in those numbers and see if I'm right. 2.34. My p-value is 0.0394. All right, and point estimate is 25. All right, and then you guys can do this. What are the estimates of the population mean? All right, you can figure that out, but let me check my work just to make sure. Bam, bam, and bam. All right, so mat mean. So you just scroll over. What is your mat's mean? You plug that in and so on and so forth. All right, hopefully that makes sense to you all. Let's keep pushing. Let's go to 10.29, please. Same concept, plug in for the two samples. Hopefully you guys are seeing this over and over again. So that way it's not tricky to you. You can figure this stuff out on your own. All right, 29, let's see. All right, so 29, obviously this is a right tail test. Plug in what you know. And this is proportion, all right? So we got that. My proportion is 0.22 and 0.15. Hopefully you know that this is equals to this number times this number. This one is equals to your big number times your proportion value. All right, and we're gonna say, yep, the hypothesized value is 0. So you got everything, y'all, you got everything. What is your p-value for a right-tailed test? Scroll down, scroll down, scroll down, not two-tail. In my example, it is just for a right-tailed test. So what is it? What is it? What is it? Check your work. Let's go. Let's go. Let's go. Let's go. All right, good work. Plug it in for yours. Yours might be a two-tailed test. Grab the two-tailed test. If yours is a right-tailed test like mine, grab the right-tailed test value. All right, let's go on to 10.35, please. All right, I think that was the first one, number 3. All right, same concept, y'all. Plug in what you know. Plug in what you know, and then get it to flow. All right, here we go. Here we go. All right, and then 14, 11. All right, this is a proportion. Be careful with this. So the total rooms is, I got to switch these numbers up, 1750 and 1700. All right, the count for response is 1505, and this one is 1411. How do I find this? It's equals to my big number. Actually, it's my small number. It's my small number divided by my bigger number, and that gives me my proportion. So that's equal to my small number divided by my bigger number. That gives me my proportion. So then the question is 0.86 or 86% statistically different from 83% using this sample information that we have up here? So if I scroll down, if it's a two-tailed test, yes, they are statistically different. All right, I will reject the null hypothesis. So in this example, you guys can figure out, is this a right tail, left tail, or two-tailed test? I'm gonna let you do that. I'm gonna let you do that. All right, you're gonna have to figure out if it's a right tail, put in the p-value for right tail. If it's a left tail, put in the values for a left tail. If it's a two-tail, yeah, you know the rest, right? All right, So plug that in. All right, so I'm just gonna look at mine real fast. Do I see anything that says less than or greater than? Increasing, all right. So I'm just gonna make the assumption, and once again, I didn't read it fully, so I'm gonna say greater than, all right, check my work. All right, perfect. I just saw increasing and I said, all right, let's go with that. So therefore you can know which one to plug in. All right, so your current year, what is the estimate proportion? All right, what is your proportion for the current year, sample proportion? All right, so I think I did, yes, current year first, plug those in. So in my case, it is 0.86. Let's check the work. Cool, cool. All right. What is my p-value? And this is a right tail test. It's greater than p-value for upper tail. And they want full decimal places, 0.0074. All right, check your work. And they also want the lower limits and the upper limits. All right. So if you see lower limits right here, upper limits right here, plug those in and you should be good to go. All right. Good work, good work, good work. Let's knock out this last one, 10.45, please. Same concept. Let's go to it. All right. So you guys are going to have to read through this one right here. Plug in your numbers, all right, of 142 cases tested in Alabama. So I'm just going to make the assumption, all right, 142, all right. 9 were found to be drug resistant. So out of 142, 9, what is the proportion? Equals to the small number divided by the bigger number. Cool, cool. This next one, 268 cases. How many were tested in Texas? 5. All right, that's a small percentage. This is equals to small number divided by your sample size. All right, so are these two statistically different or are they the same? All right, and we're dealing with a hypothesized value of 0. So what is my test statistic? All right, so scroll down and you're looking for not the critical value, you're looking for your test statistic. Okay, all right, test statistic way down here. All right, and they want 2 decimal places. So 2.37, check your work. All right, and I'm gonna let you guys figure out the rest of this. All right, and hopefully you should be good to go. But with 2 sample testing, what you're really trying to do is compare these 2 samples to see if they're equal or if they're different, if they're less than or greater than. All right, and you can make informed decisions based on that. So put in the work, make sure that you have a good working template. All right. Believe it or not, there's no exam for chapters 9, 10, and 11. All right, but still put in the work, make sure you have a working template because you might need this wherever you go. Let's go, let's go, let's go.